What's up, YouTube? So, I'm here working on a board for Zips Electric Racing. This is what we call the backplane. And what it does is it allows for modules like the safety board and the main control board to interface with the rest of the car on these two connectors. They're high density, as you can see, connectors that allow all the communication buses and power buses, control buses, come back to this. And we can monitor them via these two control boards up here, and then there's actually like a shelf, and then it can hold two more boards. So it's like almost like a layered cake, almost, all the components down. But on this board, on the bottom of this board, we have what we call the PDU, or power distribution unit, and it's intelligent. And I'm turning it on right now, and I just programmed to tell them to turn all of the channels on. What it does is, this is a little PIC 8 microprocessor, and it's actually transmitting out like what's going on with the device. And then little PIC 8, and then it goes into these shift registers. These shift registers talk to these high side MOSFET drivers. And it's really cool that these MOSFET drivers actually have the ability to measure the current on each one of those channels. So we can actually measure the current as it's going out to all of the distribution boards. And you can see one's on right now because the light's on telling it that the channel's on, and so it's turning on one of those boards, and that's one of the boards in the car. So it's actually measuring the current required to run that board. So the neat thing about that is, we can do measurement and seeing what boards actually pull the most power. And then we can also correlate that and say, well, if there's an overcurrent condition, shut the port off so we can save, the wiring, or save the board, or save both, and not destroy things like our nice, very expensive DC converters. So I'm simulating that right now, the overcurrent condition with some resistors. These are 3 16-ohm resistors in series. So I can test different loads. So this is the first one right here. And it's set pretty high right now. But if I short it out, I'm just going to pick pad. It doesn't shut off. It's pulling power, and I can't show you that, but these resistors are getting warm, which means current's flowing through them. So I'm going to fold that one back. So now it's only 2 of them. And this is a fault condition at this point. And this is all software settable. So the processors are reading the current required to that's being used in the output of these guys. And then it's seeing if that's an overcurrent condition and if it should do anything about it. So, and if it does, if it sees an overcurrent condition, it of course shuts the port off to prevent damage. So I'm trying to do this with the phone, and it's a little difficult because I can't touch a lot of things. I just gotta touch the pad. So if I just touch the pad, bang, it lights LED saying, hey, there's a fault, and shuts that light off, meaning that port's off. So I'm gonna go to the next one. It only takes a second. Bang, 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 off, and off. So it just shut all the ports down, and it'll keep them off, and the only way as of right now to reset that is a power cycle. So I'm shut it down, turn on, and it turns them all on. So in the future, we'll have that under communication control, and we can actually reboot a port remotely. So if we cleared the fault, we can reset it, set it, and turn the board back on.